Hello AP Stat students. Today we are going to do 10.1a notes. We are going to talk about the sampling distribution of a difference between two proportions. Suppose we want to compare the proportions of individuals with a certain characteristic in population groups A and B. The ideal strategy is to take a separate random sample from each population and compare the sample proportions with that characteristic. And the sample proportions will be denoted, since there's two groups, P1 hat and P2 hat. We compare the populations by doing inference about the difference between the parameters, and the parameters would be denoted P1 and P2, and we're interested in the difference. The statistic that estimates, so remember statistics come from samples, the statistic that estimates this difference is the difference between the sample proportions. And the difference between the sample proportions would be P1 hat minus P2 hat. Analyzing the sample distribution of a difference of two proportions. So we're really interested in this section in what the sampling distribution will be like. We know what the individual distributions, this should be P1 hat and P2 hat. My hats didn't show up in these notes, so please put those in there. Look like, but what about the difference? Sorry about that. It would be approximately normal if the normal condition is met. And so when we talked about one population, we knew the normal condition is n times p greater than or equal to 10 and n times 1 minus p greater than or equal to 10. But since we have two populations, we're going to have four values. So this is what we need to do to see if the difference will be normal. So we are going to do n1 times p1 has to be greater than or equal to 10, and then n1 times 1 minus p1 has to be greater than or equal to 10. And for the second population, n2 times p2 has to be greater than or equal to 10, and n2 times 1 minus p2 is greater than or equal to 10. Crazy. Okay, the center, so the mean of that sampling distribution, the difference, so P1 hat minus P2 hat should be equal to the difference in the population proportions, P1 minus P2. As far as the spread goes, the standard deviation, when combining two distributions, and we talked about this in semester 1, we can't just combine the standard deviations, we must combine the variances. And so for the variance of, or the standard deviation of the difference is going to be equal to, and this is for the sampling distribution, it's going to equal to the variance squared of sample proportion 1 plus the variance squared of sample proportion 2. And so the formula is on the back of your formula sheet. So I'm looking at it right now, and it's under for two proportions. So that formula is listed, and so you don't have to memorize it. But I do want to mention that if we go back to section 7.2, we learned that the standard deviation formula was the following. So we had P times 1 minus P divided by the sample size, and you take the square root that gave us the standard deviation. But remember, the variance is standard deviation squared. So if I was to square this, it gets rid of the radical. And so therefore, you're not going to have like these double radicals that I'm going to show you. So here's our formula. Okay, so you have population 1, so proportion. So P1 times 1 minus P1 divided by sample size of the first group plus P2 times 1 minus P2 divided by sample size 2. And so that gets rid of that radical because this right here is when the standard deviation has been squared, and that I just showed you that gets rid of the radical. So that is your formula. And we can only use that formula if that 10% independence condition is met. So let's do one example problem. Suppose that two counselors at a school with more than 2,000 students, and so the students are Michelle and Julie, the counselors are, independently take a random sample of 100 students from their school and record the proportion of students that did their homework last night. At the school, supposedly 70% of students complete their homework. And here is the population, and here is our, oh wait, I did not mean to circle that. The random sample is 100 students. Don't forget that. If you want to reset. When they are finished, they find that the difference in their proportions, so P hat M minus P hat J, so Michelle minus Julie, was 0.08. They were surprised to get a difference this big, considering they were sampling from the same population. So here are the prompts that we want to answer. The first one, describe the shape, center, and spread of the sampling distribution of P hat M minus P hat J. So the shape, we want to see if it's approximately normal, and we need to show all the values even if they are the same. So the shape, get a sample size, so it's N1 times P1, so 100 times 0.70. Is it greater than or equal to 10? So that is 70, which is greater than or equal to 10. And then we have N times 1 minus P, so it'd be 0.30. And that is 30 is greater than or equal to 10. So that is for Michelle. And then for Julie, we have 100 for sample size is still 100, times P, so greater than or equal to 10. And we know the values are going to be the same. They aren't always. So that's why whether they're the same numbers or not, you still have to show your 4 different values. And then 100 times 0.30 greater than or equal to 10. So therefore, we can conclude that it is approximately normal. So the sampling distribution of their differences will be approximately normal. And there's your work to show that. Okay, as far as the center goes, so the mean of the difference, so P hat Michelle minus P hat Julie is going to be equal to 0.7 minus 0.7. That is the population proportion. So that is equal to 0. That is the mean of the sampling distribution. Okay, and finally the spread. Now, we can use the formula because we know that 100 students times 10 is 1,000. And so the population is, and 2,000 is, or it's reasonable to assume that there's at least 2,000, well, 1,000 students because there's 2,000. So sorry about that. So the formula, we have 0.7, so p times 1 minus p over the sample size, 100, plus the second group is 0.7 times 0.3 over 100. Numbers are really nice for this particular problem. Maybe in your homework you will have different values. So you do the math, and the stuff inside happened to be 0.0042, and then you want to take the square root of it, you get 0.0648, and that is our standard deviation of their difference of the sampling distribution. Okay. Next, now that we know the mean and we know the standard deviation, we will eventually be able to calculate the probability, and that is what B is asking us. Find the probability of getting two proportions that are at least 0.08 apart. So for this particular one, and we are going to actually sketch it right here in our normal distribution, so we know it's normal. The mean is 0. The standard deviation is 0.0648. So one standard deviation above the mean is 0.0648. 2 would be 0.0648 plus 0.0648 again, so it would be 0.1296. And 3 would be 0.1944. Do that on the other side as well. So that would be negative 0.0648. And this would be negative 0.1296. And this would be negative 0.1944. Right. And we want to know what the probability of getting two proportions are at least 0.08 apart. So if this is 0.06, so I'm going to say, and that's 0.12, so 0.8, we're just going to say it's right here. So that is what we're interested in, because that's at least 0.08 apart. But then you have to look at the other side too. So here, that's also, I mean, even though it's negative, that's still 0.08. And so we are going to have to do a normal CDF, but multiply by 2, because we have to look at both sides. The right side, Michelle, left side, Julie. So we can put in 2 at the beginning, or just remember that do your normal CDF and multiply by 2. So 2 normal CDF, our lower bound is 0.08. I'm using the right side because it's positive numbers, but you can use either one and then just multiply by 2. You're going to get the same answer. So lower bound, our upper bound is some large number. You can use 10, 100, 1,000. It's not going to matter. Our mean is 0, and our standard deviation is 0.0648. And I did that, and I ended up getting 0.21699, which is a pretty high probability, actually. So should the counselors have been surprised to get a difference this big? Explain. No. There is a 21.7% chance of getting a difference of 0.08 or greater in the two proportions. And those are your notes for today for 10.1a. Have a great day, AP Stat students.